Okay. Let
Good
me know once we
afternoon.
can start presentation.
Good afternoon, everyone. On behalf of River Engineering College, it is a great pleasure to welcome our esteemed audience to today's session. Serving the nation since 1964, River Engineering College has experienced tremendous growth over the years. Our college proudly holds NBA accreditation for three branches and offers both undergraduate as well as postgraduate programs on campus. Today's session is a part of the expert lecture series, an initiative by the Training and Placement Cell and REC Pedia. This series is designed to bring together industry leaders and subject matter experts to share their insights and experience, providing our students and faculty with invaluable knowledge and inspiration. The expert lecture series aims to foster a culture of innovation and continuous learning on our campus. By engaging with experts from various fields, we strengthen our academic community and keep pace with the latest trends and the development in the industry. The mission of the Expert Lecture Series is to provide guidance, host technical discussion, and offer strategic insights that prepare our students for successful careers. Through these expert-led sessions, we strive to equip our students with the tools and knowledge they need to excel in their professional journey and contribute meaningfully to their chosen field. Today, we are privileged to have Mr. Nijas Kunju sir, Principal Engineer at ANSYS. Now, I would like to call Apoor for welcoming our guest. Over to you, Apoor.
It is my great pleasure to welcome our distinguished guest, Mr. Nijas Kunju sir. Mr. Kunju sir is a principal application engineer at ANSYS Incorporation, where he specializes in RF antennas, radar systems, signal integrity, and electromagnetic simulations. With over 8 years at ANSYS, Mr. Kunju sir has been instrumental in advancing RF antennas, radar systems, and electromagnetic simulations. His work spans automotive, aerospace, and 5G 6G technologies, contributing to the development of cutting-edge communication and radar systems. Today, he will be presenting on electromagnetic from chips to space, challenges and opportunities, sharing his invaluable insight on the latest trends and challenges in this dynamic field. So please join me in extending a warm welcome to Mr. Nijas Kunju sir. Over to you.
Thank you so much, Apoor. Now,
Thank
I would
you.
like to call Dipanshi for introducing our guest. Over to you, Dipanshi.
Thank you, Sarvath. Good afternoon, everyone. It's my great pleasure to introduce you all with Mr. Nijas Hindu, a principal application engineer at ANSYS with over 8 years of expertise in RF, antennas, radar, and multi-physics simulation. His work focuses on providing technical assistance for RF component-based arrays and 5G 6G applications across industries, including automotive, aerospace, and communication systems. Before joining ANSYS, he was research consultant at GE Global Research in Bangalore, where he worked on wireless power transfer and microwave material science. He holds a master's degree at a PhD in electronics science for Cochin University of Science and Technology with over 20 international publications and numerous conference presentations.
Thank you, Dipanshi.
Over to you.
Now, I would like to call our esteemed guest to share their insights with the audience. Over to you, sir.
Hey, thanks everyone for the warm welcome. Let's go to our topic today, unlocking the future of electromagnetics from chip to space. Before starting our presentation, may I know how many people are from the electronics background in this group? Okay. How many are other than the electronics background? That would be the best question to ask.
So basically, there are undergraduate students as well as the alumni of our college in this session.
Okay.
So we are all from different branches, most some from electronics, electrical, civil, as well as mechanical also.
So there is no particular physics for engineering because all are interconnected. I'll try to simplify my presentation in such a way that people can understand. Okay. And if anybody having a question, please feel free to stop, unmute and ask question. Okay. So coming into the topic, chip to space. I don't know how many people are aware about it of electronics and technology, right? People are familiar with the Intel, Qualcomm. They are actually developing the chips. Not only Intel, Qualcomm, then AMD is there. Then Apple used to make their own. So there are different companies make a chip which actually is the heart or a brain of your entire electronic system. But the chip is not only the component. This chip has to be placed on a PCB. And before placing a PCB, you will have this kind of a package. Then it goes to a PCB, then it will goes to a computer or mobile. And these electronic system will communicate each other between the city through wirelessly, or it can be communicated over the space, which will allow you to communicate from one part of the earth to another part of the earth. It can be through satellite, sometimes the communications, sometimes the communication can go through the fiber optics cable, which is laid across the continental. So all these areas, if you see the electronic side, the challenges and the opportunities are actually starting all the way from nanometer to kilometers of area. We will try to give you some idea about these small chips to all the way to the space and some other ongoing new trend in the industry where people can explore and be an expert in the future. Coming into this industry, right? If you come or if you divide the entire industries across the world, you will see these four companies. One is high tech, consumer electronics, aerospace and defense, automotive. So whoever designing your laptop, your mobile devices, computing devices, GPUs, everywhere you can put it under these high tech companies. They are actually making the technology which will slowly enable the other three technologies. So if you take these companies like a Qualcomm, Samsung, Intel, their processor is going to use in a consumer electronics, aerospace and defense, and automotive vehicles and everything. So, and coming into the consumer electronics, everybody is aware whatever the electronic system you're using comes under that. And aerospace and defense, it can be commercial also. So the passenger aircraft, fighter aircraft, naval ships, space, all come under this aerospace and defense. Coming into automotive, every automotive vehicle which is part of BMW, Ford, Toyota, they are also a big electronics user. And these are some of the electronics is a part of the system, right? You need to have a mechanical system to hold everything. It should be able to withstand the speed and the vibration which you have it. So even though it's electronic industry, it is still valid for almost all kind of physics, including mechanical, fluid, thermal, everything. And what is driving this all technology? So you may be seeing that every company is coming up with new versions. Who is driving everything? The driving is nothing but the money. If the money is not a primary concern, people will not invent, right? You are looking for a good job because you need to have a good salary. People trying to develop new phone, new laptops, new vehicle because they need to sell it, and everywhere money is involved. And when it comes to electronics, 3.5 trillion is the market in 2022. This may be almost like a doubled in 2024. So this is just an understanding about the industry in the area of whatever you are seeing. And let's see from the chip and manufacturing. If you see the Intel inside processors, this is a nice video from the soil and making this is as a, it's called a wafer. Once the wafer is made, they create some kind of a polish. I think I'll just try to speed up a little bit. This is a video from Intel. You can refer these videos in internet. So this is a small portion of a transistor. So nowadays the processor which is coming out in Intel or AMD, it is almost having 100 billions of transistors. And this is a one transistor inside that. So how to make these billions of transistors in a very small area? That is what all the physics and technologies. They are making a small transistors. And it's a very lengthy process. It's not that easy. You need to make transistors by one. They use photolithography to make these transistors and so many processes. And do a lot of polish. Once the base transistor makes, and these transistors are interconnected using metals. And so many metals and transistor, finally you make one small chip. And this need to be tested, cut into small pieces. And this goes into your processor. So that means a processor which is there inside an Intel or Qualcomm will have billions of transistor in it. And why the transistor is all these chips normally carry 1010 bit, which need to be processed, right? I don't know how many people are aware about Moore's law. Moore's law says that every 2 years, the number of transistor in a chips will double, right? And it was quite well following all the way to 2016. Then it came to a situation that now you are not able to make a transistor doubles every 2 years because there is a limit which you can fabricate. Now the technology says 4 nanometer technology. That means if you have a transistor with a drain and source, the gap between the drain and source is already reached in the level of nanometer, 4 nanometers, which are very difficult to achieve in physically to fabricate it. So what they are doing is to create something new technology to cover that. You will have a processor. You can choose whether you want to use a AMD or Intel processor. Then you can also choose what GPU you need, how much RAM you need, how much hard disk space you need, and finally you can make something like this. And you get these computers parts, you assemble it, and finally you can make it something like this. And you add your monitor, keyboard, everything. You have a computer. This is called a general purpose computer. Depends on your hardware configuration, you can make it. But when it comes to a new, for example, your mobile phone, it doesn't have any option to put any kind of a memory, which is when you buy it, it's already frozen. So that means your mobiles are coming up with an IC called mixed IC signal, IC, which will have a processor, which will have a memory, which will have a GPU, which will have a display unit, everything together in a single chip. This is called single system on chip devices. So compared to Intel was only the processor was making. Now this company is called application specific IC, ASIC, which comes with a system where you will have a processor, you will have a DSP module to control your displays, your communication system, Bluetooth, wireless, everything has to be properly work. So what they do is they have a simple IC where one part will have a digital section, another part will have your communication systems here, your memory will be here. So this is how the new systems of Qualcomm and Intel's system on chip will look like. So what they need to do is once they manufacture these chips, they need to connect using some wires and take this connection into the PCB so that signal can propagate from your IC all the way to this PCBs. And there are a lot of challenges in the IC packaging because this guy will be in the order of very small, and this has to be placed on a chip, which should be very strong with against vibration, against temperature, and many more. So packaging these inside a this is called a chip. This will sit here, and these are wire bonds, and then it will goes and sit. This is a solder ball, which will actually going to sit on top of your PCB. So we are talking about the chip, and the chip is now going to place on a PCB package. So what I mean is you may see this Intel processor and Qualcomm. So Intel processor is mainly the digital sections, all the 1010 bits, and its processor will happen here. Whereas Qualcomm, called system on chip, may not have that high power processor, but it will have a low power processor, the small one. But it will also have something called ADCs. It will have a signal processing system. It will have its own memory. It will have its own 5G, 4G audio system, Bluetooth systems, everything together. So this is called system on chip, and this is called CPU systems. And what was happened is, as I mentioned, the Moore's law was saying every 2 years the number of transistors in your IC will be doubled. And there is a limit because you when you buy a mobile phone or a computer, you cannot make that very big. You need to make very compact. So the chip can be make more number by if I expand its size in X and Y directions. But that limit is almost reached. You cannot extend it further. So what people are trying to do is they're trying to make these chips, multiple chips, and place it together. Sometimes I can place it something like a big chip, I can take it, and small chip, I can side by side, I can connect it. In order to increase the density, what I can do is I can stop placing side by side. I can keep it just on top of the other so that I can reduce my size in XY and keep my chip in the height along the Z direction. So that is called interprocessor and 3D ICs. So if we are using this kind of configuration, then normally 2.5D. And if you are using a 3D where the multiple IC dies are stacking in the height, then you can consider as a 3D IC. So this is how it will look like. You will have a die 1 is nothing but a one processor, and die 2 and die 3 can be a memory, another one can be a GPU. And the signal has to propagate, or signal has to send it from die 1 to die 2, die 1 to die 3. So there will be high speed interconnections from the die 1 to die 3. Those are called interposer. And as I mentioned, there will be a processor, there will be a memory. The biggest challenge for creating this 3D IC is the temperature. You might have seen a computer where you have an Intel processor. You always see a heatsink on top of it. Why? Because they are power hungry devices. It generates a lot of heat. And while it is working, and especially when you play a video game or high graphics stuff, the amount of power those processors are going to take is going to be very high, and it's going to generate a lot of heat. And this heat is the one preventing to add your dies on top of each other. So memories will not create a much heat. That is the reason. You can see the memories can be stacked together, but the processor cannot be stacked one top of each other, because as you know, when the temperature happen, the heat will always try to go in the upper directions. So if you place 2-3 processors stacked, the temperature will trap inside those processor, and within few seconds it will go for thermal runaway. So this is how the actual system of 3.5D system will look like. You will have a PCB, the signals are connected, this is your package, and actually this is the area where the interposer section is there. As you see, this is very big, but the guy which is connecting from die 1 to die 2 sits here. You can see that is that one, which if you zoom into too much. As a company, ANSYS, what we do is we help the customer to develop this kind of a small dies and other thing, because this is the one which is driving the entire other industries like aerospace, consumer electronics, and automotive. And you can see this is the PCB, you can see the package, and here is the interposer. So if you zoom in this area, you will see this particular one. And these are in the order of micrometer to nanometer level most of the time. So you need to check when you are actually sending some signal from one place to another place, is the signal is going to be transmit from one end to another without any issue or not. For example, if I have a mobile phone and if you open it, here is a shift die, and here you can see these are the memory which is connecting along the height. At the same time, you can see the processor and other places are sitting. So solving such problems are really pain, and sometimes it requires days to check, because you cannot manufacture and check it, because this manufacturing of this will take billions of dollar one prototype making. So if you make millions of such components, your price will come down, but just creating one piece is very expensive. So people what they do is, before creating such IC and packages, right, they will try to model it in virtually and see whether the system is able to work as expected or not, rather than making one and it's not working, then creating the second design, third design. Those will kill your money, those will kill your time, because if you're not able to produce your products on time, somebody else will grab the entire market and you're out of the game. So coming into the PCB, so what we have discussed so far is only this guy. I see. Now let's zoom into a little bit more. So we have discussed about this guy, wire bonds, package, and this is going to place on a PCB, solder. Some of these PCBs now coming up with antennas, because you take your mobile or laptop, it has a Wi-Fi, it has Bluetooth, everything requires an antenna for communication. So you need to have an antenna. This all has to be powered. Let's say you have a 230 volt is coming from your plug point. That will convert that into a DC power, 5 volt, 12 volt, 3.3 volt. And this 3.3 volt has to goes to each IC and power it. So it also requires power. And when it comes to these PCBs, right? This PCB may be processor. This can be a memory, or there can be processor which is sending the high-speed signal into your LAN cables. Their high-speed signals are passing through this PCB, which is not easy task for a PCB designer or PCB RF. These PCBs are now coming up with a multi-layer up to 20, 30 layers of PCB. And this line, the physical line from one pin to the connector end of your LAN, is not that smooth. It goes from the top layer, then go to middle layer, then goes to another layer. And during this transition of multiple layer, the signal will get attenuated. So the people who are designing the PCB, they have a lot of challenges, because the dielectric or PCB material will attenuate high frequency signals. Then the signals are going from one layer to another layer through wires. These wires will create a lot of unwanted reflections. The material dispersions, mainly the material which is carrying from signal from one end to another, will have different properties over the frequency. That will create a dispersion in signals. Crosstalk, if you have a signal but there is a high power noise signal also, that create a lot of noise in the communication system. So crosstalks are coming into picture. The heat which is generating in the PCBs, right? As you know, when your device getting heated up, your conductivity is going to be lower, and because of that, you will have more losses when you are heating up. So the heat is also a big problem for high-speed devices. Another big problem is when you design it, it will be having a very nice PCB models. But when you fabricate it, it won't be looks as that like smooth like what you designed, because the fabrications in the order of micrometers are always very difficult to achieve very good smooth transitions. Another thing is when you design a PCB, those PCB will have a kind of a roughness. It will have a lot of connectors and other things, soldering. Because of these, everything going to create impact on your signal transitions. So very important thing for electronics people, or think about your mobile. So the companies will give you 1 year of warranty. And during that 1 year warranty, most of the time we have seen nothing going to happen on your device. But after 1 year, you start creating issues once the warranty is over. So if you see the entire failure of your mobile phone, 55% of failure is happening because of the thermal problem. Your device is getting heated up. That's create 55% of overall failure. Vibrations can be even drop also. So the device can be dropped from your hand and fell down. That also create a failure. Another kind of drop is, for example, I have my mobile phone kept it on a truck which is vibrating on the way. those are also kind of vibrations. Normally it will take care, but it can also create a problem. Another one is humidity. So because of the humidity, your devices can get shorted. It can have fungal. Another issue is dust. So dust is accumulating on your devices. Normally it will not create a short, but will happen is because of humidity, there can be short circuit happen and getting damaged. So if you consider this entire 100% as a failure, you can consider as a high cycle where the vibrations are there, low cycle problems where the thermal cycling, thermal will not shoot very slowly, shoot ups, slow cool down, shoot ups, cool down. And another type of failure is a drop, which we mentioned. Another one is the stress analysis. People who are from mechanical and other people, others application, they will be able to easily understand. So for example, we found you have a PCB, your processor is setting on the PCB, the processor is getting heated up. So the CTE stands for thermal expansion value. So normally what will happen is this processor and other thing will have a one value, your PCB will have another value, how much is the thermal expansion is going to happen, coefficient of thermal expansion. So what will happen is if these two are two different value, and if these two are getting heated up, one will force on the solder. So the solder is actually here, right? So your package will push it in this direction, your PCB will push in this direction. That will finally, over the time, over 1 year or 2 years of time, there will be crack going to generate. And this crack going to create a open circuit. The current will not pass through from your PCB to package. That can be one failure. Second one is when your processor is getting heated up, your PCB is getting heated up, you have some areas where you tighten with the screws. And when it is heated up, every metal dielectric, what will happen? It will start expanding. Since these two areas are tightened, what will happen? This bending will happen, and this bending also eventually, if you happen for 100 times, 500 times, your devices will get damaged. So these are some of the mechanism for these electronic devices will get damaged. And a very important point if you're a electronics guy or a kind of a person who developing a product, an electronics product, and you wanted to sell it or put it in a market, it's not that easy to just design and sell it. You need to have make sure a lot of tests has been done, and it is well qualified for the test. For example, when you design an electronic system, you will see a PCB, right? You need to design a PCB, and you will have so many ICs on the PCB. You need to make sure all the ICs are getting the sufficient power. If the power is not sufficient, your IC will not work. So that is called power integrity. Signal integrity stands for if you have a processor, memory, connectors, and other thing, the high-speed signal should transmit from one end to another end without any issue. Otherwise, your digital signal will not be able to send from 1010 bit will not be able to transmit from one point to another point of your device. So that is called signal integrity. So once you qualified these two, second kind of qualification is needed is EMI/EMC. That is telling that if while my device is operating, it should not generate an unwanted radiations or unwanted emissions from my system. For example, if you remember in the old time, if you connect your mixer, right? Put it in a plug, turn it on. I don't know how many people notice your TV on the other room will start flickering. That means the mixer, when it is operating, is while it is operating, is generating a lot of unwanted noise, which is connected or transmitted to the TV through the power cord. That means the noise is traveling through the power cord and going all the way to the TV plug point, and TV is getting fluctuating. So that is a part of EMI/MC problem. So while your system is working, it should not generate such noise to the other systems. Second kind of testing is, even though if it is a noise coming into my system, I should be able to handle it. So there will be first level of testing whether my system is generating any noise or not. Second level of EMI/MC testing is when as noise is injecting into my system, that should still work without any problem. Another one is thermal integrity. Everybody knows if your mobile is getting heated up, you don't like it. So before your system is ready to create a first prototype or first device, you need to make sure that at a worst operating condition, let's say you work on gaming for a half an hour, 1 hour, the temperature will rise. There is no question about it, but that temperature should not go beyond some limit. If it is going 60 degrees, 70 degrees, your hand will get burned. So, and the processor will automatically turn off, and people will not buy such product, right? So you need to have proper heat management systems on your device. It can be an external fan, sometimes heat sinks, sometimes liquid coolings. Another one is mechanical reliability. You have your device, but if it fell down, completely gone. A drop of your mobile, it's telling that 100% it will not work. Then nobody will buy it. So people who are buying actually the mobile, they will make sure the mechanically these areas on your devices are stable. Even they do the drop test and make sure the system will not create any problem, or system should work. Even the glasses are also designed to take the drop in certain level. May not be the 100% or all the cases, but it will be able to handle such problems. So far we discussed about electronic devices, right? Like mobile phone, laptops, IC, PCB, and other thing. There are a lot of other components in electronics, especially for high frequency. People who are new to that, this is called waveguides, filters, amplifier, antennas, and so on. So this is how these antennas will look like. I will just try to give a small idea and not going very deep into this area. So antennas are nothing but, it's kind of a camera, right? So camera is, you will have a, if you have a very big aperture of your camera behind, if you are having a mobile phone, the backside you will see the big aperture, very small aperture and all. Similar way, this is aperture area of the antenna. So depends on the size and other thing, your quality of your radiations, the area of the radiations, everything will change. These are some of the antennas used for different applications. We do have a lot of capabilities of electromagnetics, and people are very less to perform such analysis for the industry right now. So many companies are looking for people who can handle such problems like antenna design, phased array design, integration of antennas, and you might have seen this kind of a radar imaging in the airports. They can, without even checking your dress, they can actually create an image of your body and see what is hiding in your under your dress. Connectivity from your mobile phone with your base stations, connectivity while the aircraft is flying, how it is connected with air traffic control systems. RCS is nothing but radar cross sections, mainly for aerospace and defense. ISAR, inverse synthetic aperture radars, cable modeling, because a lot of cables going to be routed inside the aircraft and all thing. So they need to model the cables, and multiple systems are going to be located, co-located. They should not interfere each other. When a lightning strike is happening on the aircraft, whether assume you are flying on an aircraft and lightning strike is happened, and statistical analysis says every 4,000 hours of flight, there will be one hit of lightning strike. Even though if it is hitting, it should not create any problem to the operation of the flight. They need to make sure. And we do that kind of analysis and tell that the system is going to be stable or safe during the operations. Okay, there are a lot of analysis we do. As we mentioned, this is one antenna phased array integrating with aircraft and other thing. And we can do some kind of a mission. I will try to cover that one here. So here you can see an ANSYS office ground station, and this is Earth, and this is a parabolic dish antenna. I don't know how many people are noticed these antennas. And there is a satellite which actually there in this space. It's flying at a 500-kilometer height. It's called a low Earth orbit satellite. So we can design such satellite, ground station, everything in simulation world or virtual world, and see if this satellite is flying, how my communication from satellite to ground station going to be. So first what we'll do, I will take my satellite and I will integrate my antennas and everything. And then I have my satellite blocks. So all the electronics blocks in the satellite, I can integrate it. Similarly, I will integrate my all ground station areas like parabolic antennas and everything. And a lot of simulation data also can be put in inside these blocks to get a very accurate result. And once it started, we get satellite, it's here, ground station is here. Now this is started having a communication. So you can see this is called a constellation diagram in communication system, which indicating I'm able to decode what is a transmitted signal at the receiver side. This is a transmitted spectrum. This is a received spectrum. We can see the parabolic antenna is trying to scan or looking towards that receive the satellite, and it is looking like this. So you can see the satellite is here, ground station is here, and it is going. The LEO satellite having a property within a 10 minutes time, it will travel from one side of the Earth to the other side. Within 10 minutes, you will use the communication. So it almost like a 16 plus times around the Earth every day. Now I lost my communications. So you're virtually checking how the communication from ground station to an satellite to a ground station is happening, and when the satellite is flying at some particular height. So now the idea was trying to say we just touch based on a chip, which is an Intel chip or Qualcomm chip, all the level to PCB. And now we kept those electronics like antennas and everything on a space. And we have seen how the space is going to communicate, or satellite is going to communicate with your ground stations. So this covers your chip all the way to the space, but there are so many other applications which we are very much evolved or very, very fond of. One is the telecommunications, right? So everybody having mobile phone. So if you see now we are living in the area of 5G technologies. So I don't know how many people of you are familiar with 1G, 2G and 3G, but 1G to 2G actually mobile. So there was a time you need to have only land phone or a booth where you need to pay money and make a call. technology with the 1G, then with the 2G, and you can have a mobile phone, you can go anywhere and have a call. So it will allow you to connect over mobility without any wire. And you start using little bit of internet during the 3G time, but the speed was very small. In 4G, what happened? The internet became very fast in 4G, and people started using Facebook, Orkut. I don't know how many people used Facebook, YouTube's, and other things. Social media become very strong during the 4G technology time. And if you see these all technology from 1G, 2G, 3G, 4G started in 2010, yes, and 5G started across the world. So every time 4G to 5G or 5G to 6G, you will see a 10-year gap. And 6G is not yet released. It's coming in 2030. Most likely in 2030 it will come as a first thing, and that will be connecting human with the digital world. So I don't know how many people are might have seen these English movies with a lot of holograms, augmented reality, digital twins. These are the few technology going to be enable or give to your hand during the 6G time. So currently, the speed at which 5G systems are working is not capable to render these kind of high quality videos and other things without a delay. You need to have a very high speed internet connectivity. Wired, yes, through wired you may be able to do it, but wirelessly 5G is not able to handle such speed. So that's the reason, and people are involving or developing new technologies for 6G, which eventually going to give you these features in your hand. And unlike your mobile, people going to have a augmented reality devices or this kind of a hologram kind of a device where you can virtually talk with other person from your home. So coming into this 5G technology, people you were using a couple of frequency band, and some new frequency band is also got allotted for 5G. And 5G, the advanced 5G is yet to release in India and other part of country. There is a lot of development is still going on. Maybe next year, the 5G advanced will be released. The people are now working on 6G area, 5G to 6G, where 5G is talking about a peak data rate of 20 gigabits per second, where 6G going to talk about 1000 Gbps. So almost like a 200 times speed up. And latency is nothing but if you ask for some data, how much time it's going to take to respond. So 1 millisecond is for 5G, and that's going to reduce to 0.1 millisecond in 6G. And some of these speed and other thing compared to 5G, you can compare here. In 6G going to be even faster. That's what I want to say. And not only that, 6G is 5G, these are the spectrum which is allotted. And in 6G, there are some new frequency bands are allotted for different applications. All these high frequencies are mainly for short distance communication and sensing applications. There are few new technologies are coming. It's called intelligent reflective surface. So there will be kind of a surface where the base station antennas will radiate. All the buildings will have some kind of a pattern which will reflect the energy and focus towards you rather than radiating to some other directions. It will reduce the power usage because you are not going to radiate unnecessarily. The energy will be always focused towards the user so that your net mobile will always have a network connectivity. And this can be used for different application, different areas. So there are a few new technologies are coming up, something called reflect array. I may have antennas, and this is a part of intelligent reflective surface. You will have some kind of a pattern. When the energy is hitting, it will tell you which direction that's going to radiate it out. And this is called a radiation pattern, indicating I can control the radiation from this particular antenna to different direction using this element. This is another type of pattern. So we are developing something for 6G. Another technology called orbital angular momentums antennas, that is also coming up as a 6G technology to multiplex. So time domain multiplication, frequency domain multiplication, some similar way. There is one more multiplication technique is coming. It's called orbital angular momentum techniques. So kind of toolkit is also developed. People can design such systems. A lot of challenges are also coming into 6G because it's going to operate at very high frequency, up to 300 gigahertz. And during this frequency band, there are a lot of atmospheric absorptions are there. And generating such high frequency is not that easy. So there are new techniques has to be evolved so that we can generate the frequency for these areas. Another big area where these electronic systems are developing is on the automotive. People might have heard about driverless vehicles, right? So normally in driverless vehicle, if you take it, you need to take a decision whether you need to brake it or accelerate it or take a turn based on some sensor. So which are sensor? One is a radar, camera, lidar, ultrasonics, and GPS. So people are familiar with the camera. Lidar is called laser emitting radar, kind of detection of range and mainly the range detections using lidar, laser. Camera is mainly to identify whether it's a person or who is there in front of you. And radar will detect target speed and its velocities, speed and range and angle. And GPS is identifying the location of your current location based on the global positioning system. Ultrasonic sensors are very common. You might have seen in the vehicle bumper, which can be used for up to 6-meter target detections. These all sensor will come and tell that, okay,